So the next we talk about sampling. Why you want sampling? Very simple. When you get the real data, you want to use your own eye to exploit it or do something too big. Most of the time, even the computer to do it is too big. You don't want too many data to understand it. And typically, how many is too many for the human? How few is too few? A magic number in statistics is your sample size need to be about 30, right? But not too much about 30. If you don't have that number, you need to use a little bit of different distribution. Like instead of a normal distribution, you need to use t testing. So when you do the sampling, means you want to reduce the size of the data, but you do not want to lose the information or change the information, distort the information. You want to keep the information as true as the original data, and but the size is much smaller. Human beings learn by learning from examples. So is data mining, the learning from the examples. Found this very well designed example. That's the whole art of teaching. Everybody after a couple of years, they know what's the concept, how to talk about the definition, how to do the calculation. But what kind of example will be representative to tell you all the possibility of the cases, the most important? That will be the art of teaching and also machine learning. So sampling, again, you need to try to most representative to your data population. And your data population could be a million data, like the household income, for example, in the United States, or the polling service of the Republic and the Democratic. Nobody really go through every household and call everybody to see you're going to vote for who, but their statistics is very accurate because their sites typically run through 2000s, I think. Like the Gallup poll. The Gallup is very good. So the point is, I really have no clue what is the true mean of the whole population. I have no clue what's the true standard deviation of the population. What I'm giving you is this little bar in here, and that sampling average, and this sampling point with percentage is all an estimate of the true population. But we need to have the theory. That the theory is beyond this class. You don't need to worry about it. Like statistics, mostly concerned how trustworthy of your sampling based on the data size and the variance comparison. We don't go that much, but just to show you how we do it. First, you can think about what kind of finite population and what we are doing all finite. That's the good news. Infinite is the math concept in calculus, but not in here for computer science. And you look about the correct card numbers, the inventory, product, or organization membership, who you're going to vote, whatever you want. And then there's two numbers. Little n is what you're going to really inspect. That's the sample size. Capital N is the true population size. And then these two ratio is also important. And basically, you determine your little n depends on two factors. First, the accuracy you want about your sampling. Second, the time you have, right? It's the trade-off. The shorter time you have, the small sample size you have. In medical record, the cost, how much money you can collect those data. That's a bigger event. Issue you need to make a decision. So we do a point estimation. And what that means, the point estimation, we use the data from the sample to compute the value of the statistics about the whole population. So what's the difference between probability and the statistics? Any clue? Summarize it. We know this is the flip side of the coin, right? Right? And the probability talking about if I know everything about this bucket inside, and I will tell you what's your odds if you pull out a handful. And if I know how many white marble and the black marble inside of the bag, I know everything about the population, and then later you get a handful 5. So what's the possibility everyone you got is white? And that's probability. And the statistics is the reverse. And I really do not know how many white marble or black marble inside the bag. I just get a handful 30 and I'll count. And then if I count, I have 20 white and 10 black. I may assume inside, if we have 3,000, that may be most likely 2,000 are white and 1,000 is black. Are you sure? Well, that's statistics. Everything could have a bit of odd, right? That's called lucky or unlucky. So most of the time you're in there. So these two sides are the reverse. However, this is connected. By one course, we need to know how many you need to pull out from this 3,000. Then you got confidence. You know it's right. You might think about if I got 30, I got 20, 10. If I got 300, I might not get 200 or 100. Then you're going to wait a moment. What's wrong with that? The more you get, the more accurate you get, right? Close. But the trade-off is how many is too many for you? The cost. How few are too few? What's the number? 30. Cut to about 30 on that. If you have a short time. Because in statistics, 30 you use normal distribution above, and if you are below that, you use t-distribution. Because this capital N make a difference. If anything above 30, we just believe this little n over capital N, anywhere have the 5% or above, you're just good. That's the 5% of the sampling. The little n over capital N, you try to get 5%. Okay, then what you do? You need the average, and you need how much you spread it, the standard deviation, and you use the point estimate about the proportion, and you put the bar means you are not sure it's the truth. It's just an estimate.